So let's do that simulation. So let's, I guess, make a geometry node here and call this orbs sim, something like that. Let's go in there. Let's make a box. That's actually quite a simple thing that we need to do. Let's transform the box down a little bit. And let's make a pop network. Essentially, it's just a pop network. Right, and we're gonna emit from our pops, and we're gonna use the slightly bigger box as a collider. Let's go in here. And let's say dollar frame below frame 3 or something. Maybe. All right. Let's add a pop force. So now if we play, they're gonna move all around the room, which we don't want. We want a static object. Which we're gonna merge in. Static object is gonna be op input path 1. So that's going to load in the other object. Let's turn off display. We're going to change some stuff on the collision here. So what we're going to do is, if you check collision guide, you can see it will create a, it does volumetric collisions, of course. That's how most collisions are done inside of Houdini. Oh, and I'm turning it way too high. Okay, I don't want to do that. Let's make it 100. Or 70, 60. I want to invert the sign. If you do that, it means that instead of the outside or them bouncing like this, they would stay inside. So they can't go outside of the box now. So if I now play, you're gonna see what's gonna happen there. I should probably do a laser scan. Let's do a surface offset. Where is it? -0.1, -0.5. Yeah, something like this seems to be pretty okay. Let's maybe do a little more sub steps. Get some. I mean, this is really fast anyway. We could do like a couple more noises. Right, so now we have a couple of things bouncing around, which is kind of cool. So if we just go in here, we just want to, let's go in there. Let's load just our pop object. Right, so we know we have these points here. Let's cache these out. Let's call them orbs. Let's do a little bit longer sequence, like 450 or something. We don't particularly care for looping these because they're like very small detail. You don't really notice it because they're like inside of the thing. So as long as we have, so let's do a time shift and let's just offset these a little bit so that they're already moving a little bit in the beginning. And now we just have these nice things. If you want to visualize it a little bit better, you could also like add a trail and then do an add. We're not going to use this for rendering, but just showing you how you can do that by group, by attribute, and then type ID. And now you can see kind of what they're doing. But we're going to just render them as points, so we don't care for that. We might trail them a little bit later. I did do that because it looked cool, but we don't necessarily need to do that. All right, so now what we need to do is we need to sort of copy these on our original boxes. All right, so now that we have our little sort of movement thing, by the way, maybe I want a little bit less of these. Now that I'm thinking about it, so maybe I'm going to make this like 2,000, 3,000 I only had a couple in my original. So maybe I'm going to do a little bit less of them. So it's just something like this. Maybe this is even too much, but we will see once we start doing the lighting and shading when we have it in the because it's going to start refracting and stuff. So it's going to be too much a little bit too quickly. Anyway, what we want to do is want to put those on, want to copy these on our original boxes and have them move with the original boxes. So let's make an object merge. And we can just go to our NDR boxes. We can just put it in here and put it into this object. So if we then have a look in here, then and there's, by the way, one straggler there that's not being sucked into the thing. I guess it was too far out of range, so it was never sucked in. Don't really notice it. We could probably just blast it away, if I'm honest. We could leave it there or just blast it away. I think I had one or two in my original thing as well. Like now I blasted it away, and honestly you're not gonna notice that there's one less box. So doesn't necessarily matter that much. So let's just have the one not be there. Right, so now what I do is we wanna copy our boxes here. Let's just first do it maybe with just our regular box to just test it out. So copy the points. So I want to copy them onto this thing, and our geometry here is packed geometry. So that means they're treated as points. So you can see like they're treated as points. Like if we were to put an add here, you can see they're just points. If I delete geometry, keep the points. Don't necessarily need to do that for now, but let's just, we can also just copy on this. So let's just put target points on there, and let's copy. Let's just first do it with a regular box, so it's a little bit easier to see what we're doing. And you can see this is going completely crazy. Probably want to pack this as well. So this is going to be completely crazy. So what we want to do, they're way too big. Let's create a p-scale. So attribute create p-scale to sort of scale them down. So if we just scale, you can see now they're more of the same scale, but there's still some weird stuff. Like they're not really, if we template this in the correct position. Well, it's because our geometry here has a pivot attribute. And the pivot is not in the center, and we want the pivot to be in the center. Remember in DOPS we did some stuff with setting the intrinsics for the pivot and stuff. We want to sort of delete that. So I guess we can go to attribute delete and just delete the pivot. Right, so now you can see they are sort of in the correct position, but they're oriented a little bit wrongly. That's because our original box here has a little bit of rotation, right? So if we go into the, where is it? Oh yeah, Orb Sim. So we started off with, oh no, not Orb Sim, the regular simulation. Like we have it here on the right. We have the original boxes rotated slightly. So we kind of want to match that. So just match it with 30, 30, 30. Like that. And then we can also see that we can make the p-scale a little bit bigger. Right, so that's correct now, but you can see if we start doing this, you can see they're still sort of, you have this weird rotating thing. That's because we're offsetting this, and then it's gonna do all kinds of things here with the orientation, and then it's not gonna end up in the correct spot. So what we wanna do instead is we wanna sort of say that, okay, what we wanna do is we wanna copy them here in the original position, on the original frame, so frame 1. So then we have a reference position, and you want to use this transform pieces thing again. So what do you want to transform? Well, we want to transform our geometry. Then we need a template point. So I guess let's make a time shift. We could do maybe this time shift down or at the top, so we already have something. Let's do the add above that, right? So template point, or the rest points, that thing, and template points thing above there, right? So now you can see it is working correctly. So what we're doing here just is, like I mentioned, we're sort of just copying them on the boxes, but nothing is happening here. We're just doing, and we're setting here the orientation of the box to sort of match whatever we did. We match the scales, and then after that with transform pieces, and remember we probably need the add because it might, yeah, like it's not gonna work with the, probably with if we disable this thing. I'm not sure, but we had the bug before, right? Oh, okay, it is actually working. I guess it just doesn't work when we do the p-scale thing. But so what we're doing is we're just first copying it, and then we're doing the transformation after. So this is just going to transform by the attributes that are on here. So the transformation, the orientation, so we have all of this stuff. So, but now it already takes into account the sort of the new rest sort of orientation that we set here. And then after that is going to transform them from that position based on the position and the orient in the incoming simulation. So I hope that makes sense. So yeah, what we can just do is just replace these boxes with our Orbeez. Probably there are still, it's way too many. Let's just decrease this, because I think probably need to do that anyway once we do the rendering. So maybe let's just already sort of, I mean, it's super fast, so we can always just change it if we want. So yeah, now we have our orbs doing cool stuff. So these are going to be nice with the rendering. So maybe something that I didn't do in my original, but what we could potentially also do is we could time offset a couple of these things so they don't all have the same animation. Because you can see right now they're sort of the same. Probably might be interesting to sort of offset them. I didn't do it in my original, you don't really notice it, but let's just do it for the tutorial. So since Houdini 18 or something, there's this new thing called a variant attribute. So if you go on a copy to points, example over here, you can see there's a piece attribute. And that piece attributes let us select like what piece do we want to sort of select. So let's first copy the transform, just put it before the time shift. Let's have a couple of variations of our time shift. Let's maybe also just write out a couple of more frames, so we have a little bit more time offset to work with. So let's do 550. All right. So let's just do, so this one has an offset of 20. Let's do another one of 40. Let's do another one that has 60. All right. So something like that is probably pretty cool. So then we have that. Now we need to merge these together. And we're going to set a variant for each of these. So which variant do you belong to? So we can just create do an attribute create. Call it variant. Let's make it integer. Right. I'm just going to say this is variant 1. Let's just do it variant 0, by the way. Variant 0, variant 1, and variant 2. So we're going to have 3 variants. So if we check the attributes here, we have variant 0 to 2. All right. So let's enable on our copy here. Let's also enable variant attribute. And now we need to set a variant attribute on here. So I'm just going to do that with a wrangle. So let's make a random sort of attribute, and our points here are static, so we can just use the point number. So let's create a random value, so random based on the point number. So this generates a 0 to 1 value, right? So we want to fit this. So R fit 0, 1. So it is already from 0 to 1. So that's why we can use fit 0, 1. What do we want to fit? We want to fit R. We want to fit it between 0 and 2. Now what we will get, if I write this out, just this is not what we're going to use, but like f at test equals R. You can see we get a random 0 to 1. However, we want them to be either 0, 1, or 2, right? So if we type rint, we will say round to integer. We press enter. you can see now it will round to the closest integer. So if it's 0.3 or something, it will round to 0, it will round to 1. And we don't want it to be a float, we want it to be an integer, because else it's not going to work. So you can see we just want it to be an integer, and we don't want it to be called test, we want it to be called variant. So very simple way to just do this in Vex. There's other ways that you can do this with multiple nodes and just casting the type. But in this case, I'm just gonna do it like this. So it's gonna give you a little error here that we're casting a float to an integer, but this works fine. So you, yeah, from float to integer, I guess you would need to do it like this if you need to. So like if you do this, then you implicitly tell it to be an integer, but the end result is the same. So, but now we get rid of the error. Create rand. Right, so now this thing will, it's probably difficult to tell, so let's assign a color to them so we can kind of see. So let's make this one red. Let's make another one like green. Right, so now you can see we get like a variation. So if we are now to go to transform pieces. Again, we don't really need these colors, but yeah. Right, so we have that stuff. Now there's another thing that we need to fix here because they don't really have proper velocities. So because they have velocities. By the way, we don't really need to pack this, I think. Oh, we do need to pack them, sorry. But the problem here is that the velocities that they have, that we're gonna use because they need motion blur, right? The velocities that they have are from the original point. And now you might say, okay, but let's just unpack this whole thing down here. So let's have a look here. So you might say, okay, let's unpack it. So we have our back 2 points. So we're at 1,000 points and then put trail, right? And then we could get velocity and then actually it is actually working for some reason, which I didn't expect. Okay, the point count doesn't change here. So this is, okay, yeah, we don't have any points dying. If you had points dying in your simulation, then we would have a problem. Maybe I could show you what the issue would be in that case. Let's just show you what, I'm just going to show you what the issue would be. So let's just keep it activated. Let's do a birth rate of 5 and then save it out. We're going to change this later, but then I can show you the issue that we might have had. All right, so here you can see we have this jumping around, but because we had a life on this thing, so these things have a life. So like we could also, like if we have a life expectancy of like a random life expectancy, for example, like 1. Let's increase this a little bit. It's probably going to be even more prominent. Because what the trail is doing, it's going to sort of look at the previous frame and then it's going to draw a vector. So between the current frame and the previous frame. But if the point count is not the same, well, then you get, yeah, this stuff, because it cannot really match them. And now you might say, okay, well, but Tim, we can match this by ID, right? I've done that before. But you can see it still doesn't work. Because what we've been doing is we've been copying stuff, right? So these things, the points that we have here, they definitely have IDs. So, I mean, they have IDs, right? So they have unique IDs. But if we copy them, and if we unpack them later, check the IDs, you can see we have multiple of the same ID. So that's not really gonna work either. So what we need to do is we need to reassign their IDs to do that. And again, in the setup that we have right now, you don't necessarily need to do this, but I figured it might be interesting to show this anyway, because this might be something that you run into more times during production, and you need to assign an attribute in order to be able to create this stuff. So maybe as an exercise, try for yourself, see if you can come up with something to do this before I sort of explain how it works. So I'll give you a few moments to sort of pause the video. And if you don't know, then well, then I'm gonna explain them in a couple of seconds. So 3, 2, 1, go. Okay, so essentially what we need to do is we need to come up with just a simple algorithm or something like that to essentially make a unique ID. So something we could do, and this is gonna depend also on how many points you have. Like if you have a lot more points, it's gonna be a lot more tricky because there's a lot more room for error, sort of, to not have something be unique. What I'm gonna do is I'm gonna put down a connectivity here. And again, this is not necessarily the best way to do it. It's just a way that I'm gonna do it now. So we're gonna generate a class attribute. So we're gonna get this, we're gonna get a class. And let's also then generate here on the impact. Let's transfer the class to our points. Let's check our IDs. All right, so now we have a class. So essentially what we're going to get each because these are packed, right? Each thing here. So now we have a class, and then within the class, they all have these IDs. So, but you can see there's a sort of, now we have a class and we have an ID, and the ID is gonna be duplicates, but so yeah, let's just try it. So here we have this issue. So now we need to sort of make a wrangle to sort of come up with something that doesn't have any duplicates. So what I generally do is just fit and multiply a whole bunch of values. And again, there can be like you can have overlaps. This is where something like cryptography, if you know into that, comes in. It's like that's a whole area of expertise of generating numbers that will never repeat. So it's an entire area of expertise, but we're just going to do something very simple that for our use case here doesn't generate any duplicates, but will probably generate duplicates if there's enough points. But we don't really care for what we're going to do here. So yeah, I guess let's create a couple of random numbers. So let's say float R1. And let's say that we want to say that this thing is, well, this is not necessarily a random number yet, but let's grab, for example, the ID. Let's multiply it by the class. So we get a random number. And then let's multiply by the ID again. So if we were to write this out, we were to get, for example, f at r equals r1. Right, we get a whole range of numbers that get a lot bigger. This is of course not random yet because we need to do some other stuff here. So let's do another one. Let's create float, let's say r2. And let's say that we want to do a random based on, I guess, our R1 times the float from our ID, and let's multiply it by some random number that we make here. And one closing bracket, I think, do we have? Oh, need to have an equals. Right, so I'm generating a random based on this thing. We're gonna do it times a float based on the original ID that we have there, so that we already get something more random. And then let's say that we want to create an ID2. Let's say I add ID2 equals the thing that we generated there plus the original ID. Let's round to integer this in case it's not an integer. Let's declare that it is actually an integer. All right, let's have a look if we have something that's actually sort of unique. It looks like they get a whole lot bigger numbers, but there's a whole, like you could do more stuff. You also have like a what is it called? I forgot what the name was. You have a random function built into Houdini. Oh, I looked it up, by the way, and it's actually called random shahash. So it hashes a value. So like you could do even other things. You could say that let's say my string equals concat. So generates a no, it was sorry, itoa, or then we need to say that, let's say integer r3 equals integer based on r2, and then we could say itoa r2. So then we could generate a string from our number, and then we could do this thing, random hash. So I guess integer r4 equals, I keep forgetting what it's called. Let's open the thing. And then we could do the string like r3. Group. We need to, oh yeah, it needs to go under. Oh, and what's called my string. R4, and we could say R4 plus ID, and then we can also get negative numbers here. But anyway, there's a whole bunch of sort of, and we probably need to declare here that's an integer. Anyway, there's a whole bunch of things that you could do to sort of randomize your numbers. And actually there are, oh, we need to put ID2 here. Right, anyway, if we play now, and you can see I think there's still probably some overlaps. You can see there's an issue here. So I think I'm gonna just remove my hash thing, because I think that was generating some extra stuff. So probably if I just do it like this, this is gonna have better results. Let's just try. All right, so no collusion found. Quick maths. Yeah. Anyway, so now we have these unique IDs, so we actually generate proper velocity here. So I kind of hope that makes sense. I know this wasn't necessarily something that you need for this, but I figured this would be interesting because this is an issue that you run in like quite a lot. If you're doing stuff like this, like you need unique IDs a lot of the times. So I figured this would be an interesting way to sort of include this into a tutorial. Maybe I'll do a separate just other tutorial for this as well, because not everybody might see this part. But anyway, now we have these things. I guess we could output. I just put an out here. Or did we already had an out? Just copy that. All right. So now we have our shiny colored boxes. And why are they not inside the thing? All right, that's because, yeah, all right. So beautiful glowing orby things in here. So yeah, that's that. Let's continue.